Educational administrators frequently approach generative artificial intelligence as if it were a static software tool, one that is purchased, distributed, and expected to remain unchanged. But AI operates differently. It is subject to temporal degradation. AI models decay over time as their operating environments change and underlying data assumptions erode. As data shifts post-deployment, model performance drifts. A high-performing asset in January becomes a silent liability by December. While standard SaaS products follow a linear lifecycle, AI models require continuous cyclical maintenance and active monitoring to maintain their accuracy. Subjecting a dynamic, decaying AI asset to a rigid, traditional IT procurement process creates a persistent operational vulnerability that standard software models cannot address. This procurement gap leads directly to unmonitored experimentation, where individual teachers deploy unvetted AI tools in student-facing contexts without institutional review. These rogue deployments trigger immediate legal and ethical risks. They involve unauthorized data transfers, violating privacy laws, and introducing unchecked algorithmic bias. Most districts respond with reactive governance, attempting to write regulations and enforce limits only after the technology has already been deployed and caused an incident. This reactive approach causes severe reputational damage and creates immense technical debt, as staff must eventually retrofit compliance onto systems that were never designed for oversight. Avoiding these failures requires governance by design. This strategy integrates specific policies and guardrails into the technology's lifecycle from the first day of development. Engineering governance at the start of a project is consistently more efficient than trying to fix a non-compliant system after a regulatory fine is levied. This blueprint visualizes the first physical layer of a responsible AI architecture, the data foundation. Achieving historical data adequacy and semantic consistency is a non-negotiable requirement. The raw information must be cleaned and structured before any AI model is engaged. Siloed or biased data within a district will be amplified by AI, scaling existing organizational flaws rather than solving them. Failing to address this foundation early leads to immense rework costs. Administrators are often forced to rebuild entire data pipelines after an AI system has already been deployed. Embedding automated data quality protocols at the design stage prevents these downstream failures and ensures that model outputs remain reliable. Lacking a rigorous data foundation means an institution is simply using advanced technology to automate its own operational errors. Effective governance moves through a phased progression, transitioning deliberately from awareness to piloting and never moving directly to district-wide expansion. This schematic shows the pilot phase. It acts as a gatekeeper, restricting the AI tool to a tightly controlled environment for 30 to 60 days. During this period, the tool must be monitored daily against strict go-no-go success metrics. By comparing the AI's performance against a pre-established baseline, administrators can identify unexpected behaviors and disparate impacts before they reach the general student population. Rushing past this pilot phase to reach full-scale deployment is the primary avoidable cause of district-level AI crises. These 5 critical K-12 policy domains must be codified and documented before any student-facing pilot can safely begin. Domain 1 establishes student use boundaries. This policy provides a clear dividing line between permitted AI applications and prohibited activities. Domain 2 defines teacher experimentation limits. This clarifies the professional latitude teachers hold, ensuring that the institution, not the individual, retains accountability for deployment decisions. Domain 3 addresses academic integrity. Modern honor codes must shift away from binary cheating models toward a nuanced spectrum of AI disclosure and permitted use. Domain 4 focuses on data governance. It mandates rigorous vendor vetting to ensure every tool meets the privacy requirements of FERPA and COPPA. Domain 5 establishes board-level expectations. It requires district leadership to formally approve the AI governance framework to provide administrators with clear structural authority. Codifying these 5 domains transforms AI from an unmanaged liability into a regulated capability that protects students and staff alike. But local policy is only one part of the solution. Because AI risks are borderless, local governance must connect to international standards. Borderless risks, like algorithmic discrimination and epistemic injustice, require frameworks that operate beyond individual school districts. This is where the UNESCO Ethical Impact Assessment, or EIA, provides a gold standard for institutional protections. As this diagram shows, the EIA tracks the entire lifespan of a technology. It cycles through 5 distinct phases: pre-design, development, deployment, use, and decommissioning. The framework mandates cross-disciplinary stakeholder engagement, requiring educators, legal experts, and ethicists to jointly evaluate every deployment. Adopting this global framework enforces vendor accountability and ensures that local AI implementations meet the highest universal ethical standards. The human consequences of unmanaged AI are immediate. Without governance, these systems can inherently amplify existing systemic biases within an educational institution. Informal, unmonitored use creates a new category of educational inequality. It amplifies digital privilege, providing already advantaged student populations with a significant lead others cannot easily bridge. Transcultural governance frameworks ensure that AI tools are equitably adapted to serve the diverse needs of every student, rather than favoring a single demographic. Equity must be mapped into the workflow from the start, as it cannot be effectively added to a system after it has already been deployed. Protecting students and ensuring fairness requires leadership to prioritize deliberate, protective governance design from the very first entry of data. Governance by design serves as a deliberate risk management strategy, protecting the district's long-term stability as technology evolves. The financial data is definitive. Integrating governance during the design phase reduces long-term compliance and rework costs by approximately 30%. Rigorous data protocols and controlled pilots transition AI from an unmanaged institutional threat into a reliable, equitable asset. In our current era of rapid, exponential technological growth, unchecked experimentation must never outpace carefully designed institutional policy. To protect both the institution and the student, governance must always precede implementation.